Good morning to all of you. Myself, Professor N.V. Arpe from SND College of Engineering and Research Center, Yeola, working as an assistant professor in Electrical Engineering Department. So today we will start the new topic of subject, that is numerical methods and computer programming. And in that unit number 2 of second part of unit number 2 is curve fitting by using least square approximation method. In that topic, the method curve fitting by using least square approximation method for first order and second order equation. So what is curve fitting? So what is the curve fitting? Curve fitting is the process of establishing a mathematical relationship or a best fit curve to a given set of data points. Means from the given set of the data points, we can make the one relation, of that data point for making a one curve. It is called as curve fitting. For making the process of establishing a mathematical relationship or a best fit curve means suppose the given data point, number of given data points, from that this data point we make a one standard equation of the any curve or the relation for satisfying this data point and make a one curve. This is called as curve fitting. This relationship may be used for testing existing mathematical models, establishing new models, and predicting unknown values of the equation. This is the curve fitting. The methods for the curve fitting is least square approximation method. In that method, it is a mathematical procedure for finding the curve of best fit to a given set of data points such that the sum of the squares of the residuals is minimum. Means from this, as the name suggests, least squares means the square of the set of data points, and the sum of the square of data points is minimum. This is called as least square method. And residual is the difference between observed and estimated value of dependent variable. Residual is the difference between observed and estimated values of dependent variable. So method of least squares can be for establishing linear as well as non-linear relationship. Means this least square approximation method is used for the linear as well as non-linear relationship. Following diagram shows the linear and non-linear regression. The graph A shows the linear regression and graph 2 shows non-linear regression. This is a linear regression, means as the value of x changes, according to that the value of y should be increased. Means it is linearly proportional. But nonlinear, in nonlinear regression, it is not directly changed, but it is periodically changed. It will be periodically, means nonlinear relationship. Nonlinear means the at first point the increasing value is very small, and after the some duration the increasing value of y is suddenly changes. This is the difference between linear and non-linear regression. So we will start discuss one by one linear as well as non-linear relationship. First one is linear relationship, least square method for fitting a linear relationship, that is linear regression. We establish the relationship between the variable in the form of the equation, that is y is equal to a plus bx. This is the equation of straight line. This is the equation of straight line. So this method is called as fitting a straight line. Fitting a straight line. Consider the n number of set of n values, that is from x1, y1, x2, y2 up to xn, yn. xn, yn. Then we have to find linear relationship in the form of y is equal to a plus ba among the above set of x and y values. Above the set of x and y values. Means from that we can find the values of find the relation of straight line, that is a is equal to a plus y is equal to a plus bx, y is equal to a plus bx from the given set of. In the difference between observed and estimated value of y is called as residual, and this residual is written by r is equal to yi minus a plus bxi. Suppose r1 is equal to, suppose put the values of I from 1 to n. Suppose r1 is equal to, then equation is y1 minus a plus bx1. This is your residual. In the least square method, we find a and b in such a way that the summation of ri square, is minimum or it is nearly equal to the 0. Means the summation of ri square means the error, in the y minus ax plus bi, it is negligible, or it is minimum. Then transfer function t is equal to summation of ri square is equal to summation of yi minus a plus bxi bracket square. This condition will be satisfied when the derivative of that function is equal to 0. Derivative of that function is equal to 0. Then the t is minimum when del by t by del by a is equal to 0. Means this t value, it is derivative of a. Take a derivative with respect to a, partial derivative with respect to a is equal to 0, and second partial derivative with respect to b and put is equal to 0. That is then 2 into summation of yi minus a plus bxi into -1 means the derivative of square is 2 into given value, and the derivative of minus a is -1 and other derivative is 0. Other values of derivative, other constant value is 0, then -1 is equal to 0. For delta t by delta b, then 2 into yi minus a plus bxi, and bxi, the derivative of bxi is minus b, this is sign minus, and bxi, b derivative of b is 1 and multiplying factor is xi, then minus xi is equal to 0. Then rearrange this equation, then summation of yi minus minus plus, sorry, minus sign is cancelled, 2 is divided in that side, then yi minus a minus bxi is equal to 0. yi minus summation of a minus summation of bxi, b into xi is equal to 0. This I is in that side, and the summation of xi yi, multiply this yi into xi minus axi minus b into xi square is equal to 0. Then therefore the equation is summation of yi is equal to summation of a means n into a plus b into summation of xi, and the second equation is summation of xi into yi is equal to a into summation of xi plus b into summation of xi square. These are called as normal equations. This is a normal equation. By solving this equation, we can find the values of a and b. The summation of yi is taken from the given data point. Summation of yi, summation of xi, summation of xi into yi, summation of xi square. This will be find out from the given data point, and the line of best fit can now be formed with these values of a and b. Then y is equal to a plus b x. So this is the formula which is used for finding the value of a and b. This will be find from the least square approximation method. So we take a one problem. Fit a straight line to the following set of data points. These are the data points given x and y. X value is 1, 2, 3, 4, 5, and y value is 3, 4, 5, 6, and 8. We know the equations, that is yi, summation of yi, na, b into xi, summation of xi square, summation of xi comma xi into yi. Then we find the xi, yi, xi square and xi into yi. Then write these values of x and y in a table format. Then 1, 2, 3, 4, 5. The summation of this is 15. Y 3 plus 4, 7 plus 5, 12 plus 8, 6, 18 plus 8, 26. These are the summation of yi is 26. Take xi square. Take the value of xi square. 1 square 1, 2 square 4, 3 square 9, 4 square 16, and 5 square 25. The summation of this is 1 plus 4, 5 plus 9, 14 plus 16, 30 plus 25, it is 55. and multiply xi into yi. Then 3 into 1 is 3, 2 into 4 is 8, 3 into 5 is 15, 4 into 6 is 24, 5 into 8 is 40. Then we take the summation 40 plus 24, 64 plus 15, 79 plus 8, 87 plus 3. This is your 90. The summation of xi, yi is 90. Put these all the values in the equation. That is summation of y is equal to na plus b into summation of x, and summation of xy is equal to a into summation of x plus b into summation of x square. Then put the values. Summation of y is 26. The number of data point is n is equal to 5. Summation of x is 15. Summation of x is 15. Summation of x square is 55. And summation of xy is 90. For solving this equation, this is the 15a. Then multiply with 3. Multiply equation 1 into 3. Then equation 1 becomes 78 is equal to 5 into 3, 15 plus 15 into 3, 45b. Then by subtracting these two equations, 90 minus 78 is 20, 58, 58 get cancelled, 55 minus 45 is 10b. Then 10b is equal to 12. Then b is equal to 1.2. 1.2. Put this value in that equation. Then 26 is equal to 5a plus 15 into 1.2. 15 into 1.2 is 23. 20. Sorry. It is 18. 18. 26 minus 18 is 8. 8 divided by 5 is 1.6. The a value of a is 1.6. Then the equation of straight line is y is equal to a plus bx. Put the value of a and b. Then 1.6 plus 1.2. This is the equation of straight line. This is the equation of straight line. This will be found by using least square approximation method for the curve fitting of straight line. So understand this example or this method for the straight line. So new topic is for non-linear relationship. The non-linear relationship that can be converted into linear form by using least square method. By using least square method. The form is y is equal to ab raised to x or y is equal to ax raised to b or x raised to b. This can be converted. This can be converted into a form of y is equal to a plus bx. Y is equal to a plus bx. By applying logarithms on both sides. Then we obtain the nonlinear relation into linear relation. Is also y is equal to a e raised to bx or y is equal to ax raised to b. All types of nonlinear relationships are available. So we take a one problem. This is give the following data. Given following data, fit an equation from y is equal to xb. Y is equal to xb. B. With y is equal to bx raised to a. Suppose we take a value of y. Suppose the given equation is y is equal to a x raised to b. Y is equal to a x raised to b. Apply log. Apply log on both sides. Then log y is equal to log a plus b log x. B log x. And the normal equation of straight line is y is equal to a plus bx, where y is log y, the value of a is log a, well, b small b is equal to capital B, and x is equal to log x. X is equal to log x means we require the for calculating the x and y, we take a logarithm of x and y terms. Write x and y terms, given terms 1, 2, 3, 4, 5, 0.5 to 4.58 and 12.5. Take a log of y, log 0.5, log 2, log 4.5, log 8 and log 12.5. Make a summation of this. Log of x, log of x, log 1 is 0, log 2, log 3, log 4 and log 5. Make the addition. Calculate x square and xy. X square is the square of this column, right in that column, and xy. Multiply these two columns and put in that column and make the addition of all the columns. Then y is equal to 6.1092, x is equal to 4.7874, x square is 6.1993, xy is 9.0804. Put all this value in that equation. Summation of y is equal to na plus b into summation of x, and summation of xy is equal to a summation of x plus b into summation of x square. Put all this value in that equation and find the value of a and b. The value of a is 0.6931 and b is 2.0. But to find the value of a and b, the a is antilog of minus 0.6931 is 0.5, minus 0.6933 is 0.5, and 2 antilog of 2, b value is as it is. Then y is equal to a x raised to b. Then a is 0.5 and b is 2. Then y is equal to 0.5 x square. This is the final non-linear equation. This is for first order curve fitting. So for second order or the highest order polynomial curve fitting, to take a let y is equal to a1 plus a2x plus a3x square plus dash 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 up to be the curve of best fit for the data set, that is x1 y1 comma x2 y2 up to xn yn, using least square method. We can prove that the normal equations are summation of yi is equal to n a1 plus a2 summation of xi plus A3 summation of x square I up to sum. Summation of xi y is equal to A1 summation of xi plus A2 summation of x square I plus A3 summation of x cube up to the summation of xm is xm minus I minus 1i into yi is equal to A1 xm minus 1 of I plus A2 into summation of x1i plus up to that. Solving this, we can find the values of A1, A2, A3 up to this value. The curve of base fit now can be formed with this obtained values. So we can find the value of A1, A2, A3 from this equation. So we solve the one numerical. Shift a second order polynomial to the given data. The given data is x is 1, 2, 3, 4 and y is 6, 11, 18 and 27. The summation of x is 1, 2, 3, 4, this is 10. Summation of y is 6 plus 11, 27 plus 18, 45 plus 35 plus 27 is 62. Summation of x square 1 plus 4 plus 9 plus 16. This is 30. Summation of x cube is 1 plus 8 is 9 plus 27, 36 plus 64, it is 100. X raised to 4, 354. Summation of x into y, 6 plus 22, 28 plus 54, that is 82 plus 182, that is 190. And summation of x square y, summation of x square into y is 644. It is 644. And the normal equation is summation of y is equal to n into a1 plus a2 into summation of x plus a3 into summation of x square. And second equation is summation of xy is equal to x into y is equal to a1 summation of x plus a2 into summation of x square plus a3 into summation of x cube. And third equation is summation of x square y is equal to a1 into summation of x square plus a2 into summation of x cube plus x3 into summation of x raised to 4. By putting all the values in that equation, then 62 is equal to n is 4, 4a1 plus a2 into summation of x is 10 plus summation of x square is 30 into a3. Summation of x into y is 190 is equal to summation of x is 10 plus summation of x square is 30 plus summation of x cube is 100 into a3, a2 plus a2 and a3. Summation of x square y is 644 is equal to summation of x square is 30 a1 plus summation of x cube is 100 a2 plus summation of x raised to 4 is 354 into a3. By solving these three equations by using linear simultaneous equation, find the value of a1 is 3, a2 is 2 and a3 is 1. 3, 2, 1. Then by putting this value of a1, a2, a3 in that equation, then y is equal to a1 plus a2x plus a3x square, then 3 plus 2x plus x square. This is the final equation of curve fitting, second order curve fitting. So this is a curve fitting by using least square approximation method for linear as well as non-linear equation for first order and second order polynomial. So stop here. Thank you.